Hello students, myself Snehal Sagre and I am Assistant Professor from KK Institute of Engineering Education and Research, Nasik. Today we are going to see out the concept of smart grid in this session. So let's begin. At the end of this session, you will be able to know what is actually a electrical grid, how we are going to say or derive out the traditional power system design which has emerged and due to which there were many challenges to be covered, or we can say problems arised out, and you can enlist out them and understand and state out the smart grid concept and its advantages. Electrical grid. Today's electrical power grid is over 100 years old. If we see carefully the design and engineering structure, it is consists of a number of operational standards that have been developed to ensure a reliable electricity supply. Electrical grid, or which is sometimes termed to be a power grid, is defined to be a network which interconnects generation, transmission, and distribution unit. It supplies the electrical power from the generating unit to the distribution unit. A large amount of power is transmitted from the generating station to the load center at 220 kV or higher than that. The network formed by this high voltage lines is called to be a supergrid. The supergrid feeds the sub-transmission network operating at 132 kV or less than that. But the power station of the grid is located near the fuel source, which reduces the transportation cost of the system, but it is located far away from the populated areas. The electrical grid is mainly classified into two types. One is regional grid and the other is national grid. The regional grid is formed by interconnecting the different transmission system of a particular area through the transmission line. National grid. It is formed by interconnecting the different regional grids. If we refer out the two terms, we find they are formed by interconnection. So, what is the reason for an interconnection? The interconnection of the grid provides the best use of the power resource and ensures great security to the supply. It makes the system economical as well as reliable. The generating stations are interconnected for reducing the reserve generation capacity in an each of area. The types of interconnections in a network are classified into two types. One is HVAC link and the other is HVDC link. HVAC link is high voltage alternating current interconnection and HVDC is high voltage direct current interconnection. Traditional power system designs. This system design was based on a few simple ideas. If we could look at, the first reference was taken for few locations. Electricity generation is centralized in relatively few locations, generated by large power plants that can be easily controlled as needed. On the other hand, it is seen almost designed considering out demand for electricity. Utilities and electricity system operators continuously work to meet for demand for electricity, and this demand is relatively outspread, which occurs at random locations and varying out in magnitudes that change out in a traditional manner and not that can be easily controlled. Next, we can find out is gravity driven water systems. The power system is just like a gravity driven water system where the power flows downhill to electricity users. It is designed to deliver high quality electricity to every user under all but extreme conditions. And this delivery is controlled for the most part at the generating system station site. On the other side of the design aspect, we can find energy flows in one direction in the distribution network, that is from the sources of supply to the electricity consumers. But somehow we face some of the challenges. So, challenges of today's evolving electricity grid could be seen out at a side. So, one of it is a renewable generation which is intermittent and difficult to control. So, how is it? So, if we refer renewable energy resources which are as a part of smart grid, if we consider the wind does not always blows, and if we see out the side of solar, the sun does not always shine out when each of the customer requires up with the electricity. So, if we could find out, although there are low cost of source of clean and renewable energy, these resources may inject out power into the grid at the times and the locations that can create difficulty for the grid operators. Problems can also arise because there are random changes in the voltage on the distribution feeders, and there are issues with the fault detection and unwanted generation capacity, which all affect the reliability and the sustainability of the grid. Nextly, energy consuming equipment is changing out with the advent of new technology. As in the older section, we have seen the older electrical equipment such as incandescent lights, heaters, and motors were designed to react to change in voltage and or the frequency. But in fact, conservation voltage reduction is based on this concept. By reducing the system voltage, the electricity demand from these devices will be reduced as well. So, newer electronic devices do not respond to the changes in system voltage or frequency level, and they now dominate many homes. They include out computer, LEDs, entertainment systems, and other devices. Nextly, new protection system and technologies come up with a challenge as they are enabled out with the modern power grid to deliver more power than has ever been possible. If we consider new wire technology that has enabled existing wires to handle higher electricity current for short period of time, this can increase losses that can be more than 4 times the normal. So, it is seen while convenient and beneficial for today's grid, this type of technologies have played a role in increasing the overall system losses from 5 to 7% or 9 to 12%. Problems with the current grid. If we could find out, there are many infrastructural problems which are arising due to the fact that the system is outdated and unfit to deal with the increasing demand. Information and transparency for the customers should be having out to be maintained up with the decisions which are relative to the market, as the need is there for more information and transparency for the customers to know how the optimal decisions are being taken relative to the market so as to reduce their consumption during the most expensive peak hours. Also, the problem of inflexibility related to current grid is being seen out, which cannot be supported the developing of renewable energies or other forms of technologies that would make it more sustainable. All of these problems are addressed and could be seen now to be covered at a side by the origination of smart grid through the improved communication technology which gives up numerous benefits for both supply and demand sides of electricity market. Smart grid. In simple word, we can define it as a smart electrical network that combines electrical systems and smart digital communication technology. It is self-sufficient electric power network system which are based on digital automation technology for monitoring, control and analysis within the supply chain. One of the standard definition which we can refer for smart grid is a smart grid is an electricity network that can be intelligently integrate the actions of all the users connected to it, generators, consumers, and those that do both, in order to efficiently deliver the sustainable, economic, and secure electricity supplies. Smart grids are considered to be smart because they support renewable technologies. As a part, they help to integrate an increasing amount of renewable energy generation into the grid. They manage moves and the outages. Smart grid help the network companies to remotely anticipate and respond to problems, so they repair the crews from your local distributor and fix the power outages more faster. They can empower the consumers. As we have the use of smart technological advanced gadgets or one sort of smart meters, we can work in a tandem with an smart grid to give customers access to the near real-time information about their energy consumption and in turn understand the control over it in a better manner. Let us see the advantages of smart grid. The smart grid provides better power management technologies through its integrated system. This provides a better user interference. Along with it, it gives better protective management system in case of emergencies. It also provides a better supply and demand management. It has reduced the carbon emission technology. Also, a better quality power, lowest cost of operation, maintenance, and management for both utility and the consumer is being seen out. It provides more efficient and improved security and protection. Reading out the meters remotely has given out the convenient manner through the smart grid. Meter readers will not have to appear physically to check the meter readings. It will be all done through the IT resources. The applications of the smart grid could be further stated out in quick recovery after any disturbances in the transmission network, reduction of the generation cost, reduction in the peak demands, as they improve the adaptiveness of transmission network. They possess the ability to integrate other renewable energy sources through distributed generations and the microgrids.